All right, this is homework help for PreCalc 1.2. First question, what's the domain? That goes from, looks like negative 3 to positive 3, so we'd say negative 3 to positive 3. We can include those points as well. The range goes from negative 1 to positive 2, and we can include those points. Next question says, enter the letter of the graph of the function which corresponds to each statement. The graph of the line is increasing, that'd be C. Next one, the graph of the line is constant, that'd be D. The graph of the line is not a function, A is not a function, it doesn't pass the vertical line test, and B is decreasing. The next problem says find the domain of the function. There's two things we need to look out for with domains, and that's zeros in the denominators of fractions and negatives underneath square roots. Now we don't have to worry about negatives because that square term is going to make this bottom always positive. But we do have to look out for zeros in the denominator, so I'm going to factor it into x minus 6x plus 8. And then you can see we got a problem at x equals 6 and at x equals negative 8. There's an issue, the bottom would be 0. So it wants the greatest value that's not in the domain, that'd be this point. Negative 8 gives you an undefined value which is not in the domain. Same thing here, this time we're looking out for negatives underneath square roots, so we have factor out an x, you'll end up with x squared minus 25, which is the same thing as x times x minus 5, x plus 5. And you can graph this thing if you want. We now know that it goes through negative 5, it goes through 0, and it goes through positive 5. We know it's a cubic function, so we know it goes like this. So if we're looking at this cubic underneath this radical has to be positive, so we're looking at only from here to here. And also from here to here. The rest of it cannot be in the domain because it'd be a negative underneath the square root. So the smallest value that's in the domain would be this point, negative 5 over here. Next point is a parabola. This thing's been shifted up 19 units. You can graph it in your calculator if you don't believe me. So the domain's all real numbers. We can do negative infinity. I think you got to spell it out. To positive infinity, it's all real numbers. And then the range is from 19 on up to positive infinity. I can include 19 because it actually goes through 19. Next problem, I'm going to factor the bottom into x minus 19, x plus 19. And it wants the domain of this function. The domain's all real numbers except for when you get zeros in the bottom, which would be 19 and negative 19. So I'm going to have to write this as negative infinity all the way up to negative 19, and then they say you can use the symbol union, negative 19 up to positive 19, union 19 up to infinity. I know it's a lot to write in, especially because you got to type in infinity and not use that symbol, but that's the answer. Next problem, this is a parabola, so the domain is going to be all real numbers again. And then it's been shifted up, so the range in this case would be from 9 up to positive infinity. We can include 9 actually. Okay, next problem. You can graph these. Desmos is a great way to graph these. If you go to Desmos, you guys can just type these in really easily. Your graphing calculator also works as well. The first one's like x plus 6 equals y squared, so you can just type that in, x plus 6 equals y squared. And you'll see it's a sideways parabola, which doesn't pass the vertical line test, so it's not a function. So we'd say no. Okay, this next one is a cubic function that's been tipped over, so it looks like that. So that would pass the vertical line test. The next one is ends up being a parabola, which that definitely passes the vertical line test. Next one is a weird function that looks kind of like this. If you graph it in your graphing calculator, so that passes the vertical line test as well. The next problem wants to know about one-to-one. One-to-one are functions that pass the vertical and horizontal line tests. So this first one's a parabola. It does not pass the horizontal line test, so it's not one-to-one. One-to-one means the function and its inverse both pass the vertical line test. So its inverse is tipped sideways. It's a reflection of line y equals x. So its inverse would not. So we'll just use the vertical and horizontal line test to see if it's one-to-one. Okay, the sine, same thing. The sine does not pass the horizontal line test, so that's not. But the reciprocal function does. That's fine. That passes the vertical and horizontal line test, so that would be yes for that one. This next problem is tough because you kind of see what it looks like, and you're gonna have to use your graphing calculator for this. So when you type it in, you're gonna see this in a standard window. You're gonna see very little of it. So I'm gonna zoom out. I'm gonna go from negative 15 to positive 15. Whoops. And you're gonna have to change your Y's big time. I think I had messed with this earlier. It's like I think I went down to 2,500 and up to like 2,000 in order to see mine. You're gonna have to mess with your windows in order to be able to see it all. But you're gonna have to go down and up quite a ways. And then we have to find that relative maximum there and that relative minimum. You're gonna have to find those points because you're gonna use those to answer all the rest of the questions. So to find those, you do second calculate maximum, and you scroll to the left of that maximum point, and you hit enter, and you scroll to the right of that maximum point and hit enter, and hit enter for the third time, and you'll get the maximum, which is at negative 5, 1297. So that's really important. Let me just grab that graph actually over here. Negative 5, 1297. Now for the next point, do minimum, and scroll all the way over to find this minimum right there, the same way you found the maximum. And that gives you 7, negative 2159. Now we can use those to answer the question. It says it's decreasing on the interval from negative 5 to 7 for me, and then it's increasing on the interval from negative infinity all the way to negative 5, and on the interval from 7 to infinity. And the function has a local maximum at negative 5, 1297. That's just that point. All right, next problem is a really tough problem as well. You're going to have to graph this. So go to y equals. Do alpha y equals and hit enter to get the fraction. And do x cubed. And then go to the bottom. Whoops, that didn't work out. Try that again. X to the third. And then in the bottom, you get x squared minus 9. And take a look at that graph. Now you're going to have to change your window. So I'm going to go to a standard window. I'm going to go to zoom standard real quick. Zoom standard. And I'll see this weird graph. It's got another piece up here. And it asked me a bunch of questions. First of all, vertical asymptotes. So let me copy this over. Vertical asymptotes, you can see, are here at negative 3 and here at positive 3. Now those always occur at zeros of the denominator. So this thing does factor in the bottom as x minus 3, x plus 3. So vertical asymptotes, that's on your formula sheet. We'll talk more about this later, but vertical asymptotes always occur at zeros in the denominator. So that's x equals 3 and negative 3. Enter with a comma. Now it has a local minimum maximum at the values. Well, here's the local maximum, and here's the local minimum. So I'm going to have to find those the same way I did in the last problem. What you guys can do is do second calculate maximum here and second calculate minimum here. And then for each of the intervals, you know, from negative infinity to this maximum, you know, it's saying is it increasing, decreasing, or decreasing? Well, that'd be increasing. From the maximum to negative 3, it'd be decreasing. From negative 3 all the way to 0 is decreasing. From 0 to negative 3, it's decreasing. From 3 to positive infinity, it's increasing. And from the minimum, from 3 to the minimum, it's decreasing. And then from this point here, the minimum to positive infinity, it's increasing. Okay, it's concave up over here on the interval from 3 to positive infinity, as well as, I think you can enter a comma or the symbol or, I'm not sure, I think comma works, or it's also from negative 3 to 0 for me. We haven't talked about concavity a whole lot, so we'll talk about that in class if you have any questions about it. There's an inflection point at x equals 0 as well, because that's where it turns from concave up to concave down. And that's not something I'm going to test you over those last two questions. And the graph is fine. We just graphed it right there. You don't have to do the last part. Okay, the last problem, type this in, and you could even use the alpha y equals there to make that look a little better. Make that 5 over x. Let me get rid of this then. And then when you graph it, I changed my window, and what I did is I went to zoom fit. So if you do zoom 0, a lot of times that'll give you a decent window. And this isn't perfect. I did zoom 0, which is zoom fit. You scroll down, you'll see it says zoom fit. But it'd probably be better to change this window yourself, make it a little bit smaller on the x side of things. So maybe like -5 to 5. Might help a little bit. I don't know, not much, but anyways, there's the relative maximum, there's relative minimum, and you guys know how to find those. It's second calculate maximum for the maximum 4, and scroll to the left of the intersection point, or the maximum, hit enter. Scroll to the right of it, hit enter. Enter for the third time, and it guesses the point in between that has the highest y value, which in this case is -0.845 and -11.83. So enter that as an order pair, and do the same thing for the minimum over here. Alright, I hope this helps.